This is Math 131, section 5.3. We're going to start by talking about rational numbers. So we talked about our natural numbers, which is 1, 2, 3, 4, 5, and then our whole numbers include 0 and 1, 2, 3, 4, 5, etc. And then we said our integers, remember, are all those plus the negative numbers like minus 1, minus 2, minus 3, minus 4, minus 5, etc. So our rational numbers are ratios of integers. Okay, we usually use this form. We'll say, maybe Q is an integer, capital Q, and the form is P over Q, little p over little q, where P and Q are integers. Okay, so think of just look at it like this. We're taking an integer. I'll just write int for integers, divided by another integer. We can say integer 1, integer 2, or whatever you want to call them. Okay, and that would be our rational number. Okay, think of it like a fraction, right? A fraction of integers. Okay, so here's some examples. 1/3, 1 and 3 are both integers. 3/4, minus 7/8. We could put the minus on the 7 or minus on the 8. Okay, 1 and 2/3 is actually an integer because we could write it as 5/3. So we would put this in a different form. We would write this as 5/3 if we were to show it as a ratio of integers. Now, integers are also rational numbers because we can write an integer as a ratio of integers, and we can do that by putting a 1 underneath it. So that that 2 is really a rational number also. Okay, so is the 0. We can put a 1 underneath it. Okay, and then 15/7 is another one. Now notice the denominator is bigger on the top than is on the bottom. That's okay. Okay, so here's some examples of rational numbers. Now we have to specify this though. That denominator, the little q there, okay, cannot be equal to 0. Okay, so that little q cannot be equal to 0. And the reason for that is because we can't divide by 0. Okay, so this integer here, this one on the bottom, cannot be 0. Okay, we know what fractions are, right? So here's some examples of fractions. The numerator is the number above, okay, and the denominator is the number below. Okay, so here's some examples. 1/3, 2/9, 9 over 53 are fractions. Okay. Okay. When we have fractions, we want to make sure they're reduced. So, and we can say those in lowest terms. So, reducing a fraction, we want to reduce a fraction to its lowest terms. Okay, and we do that by dividing the numerator and the denominator by the greatest common divisor. Okay, so we looked at greatest common divisor before. Now we're going to use it to reduce fractions. So we're going to divide the top and the bottom by the same number to get the fraction in a reduced form. Okay, so here's an example of 54 over 90. If we do our factor tree like we did before in section 5.2, we would find that the greatest common divisor of 54 and 90 is 18. That's the biggest number that goes into 54 and 19. Okay, so if we take 54 and divide it, 54 and 90. Okay, and 18 is the biggest number that goes into both of those. Okay. So if we take 54 and divide by 18, we get 3. And if we take 90 divided by 18, we get 5. So our answer would be, reducing this 54 over 90 into lowest terms would be 3/5. Okay. Now there's other ways to do this, right? We could divide out numbers until we can't divide out anymore, like 2s and 3s and things like that. But the easiest way is to find the greatest common divisor of 54 and 90. So that would be the think of greatest common factor as another way. So then we could also call this a greatest common factor, GCF. Okay, is another way to say greatest common divisor. In this case, it's 18. Okay, a mixed number. Mixed number consists of an integer and a fraction, like 2 3/4 or 1 1/2. Okay. Now, when you say that, and so this thing we write as 2 3/4. Now, what it really means is 2 plus 3/4. So there's a plus there that we say, and we kind of use as a plus. There's a plus there that's implied, so it's really 2 plus 3/4, 3/4. Okay, now let's talk about improper fractions. Okay. If we have a rational number, a fraction, that's greater than 1 or less than minus 1, okay, we can write those as mixed numbers or as improper fractions. Okay, so An improper fraction is just a fraction whose numerator is greater than its denominator. Okay, so it's bigger than 1. Okay, so one example here is 8/5, right? Because 8 is bigger than 5. Okay, so that's an improper fraction. It doesn't mean it's wrong. It's just a way of showing that form without using a mixed number. Okay, now we could write this as a mixed number. In this case, it would be 1 3/5 would be the mixed number form of that. But the improper fraction form is okay. In fact, we prefer to use improper fraction form when we're doing mathematics because it's easier to work with this than it is to work with this, okay, the mixed number form. Okay, so let's talk about how we convert a positive mixed number to an improper fraction. Okay, so let's say we want to change our mixed number to a fraction. Okay, so our first step is to multiply the denominator of the fraction in the mixed number by the integer and number preceding it, number in front of it. Okay, and then we're going to add the product obtained in step 1 to the numerator of the fraction, the mixed number. Okay, so that sum is the numerator of the improper fraction. Okay, the denominator is the same, so the denominator is the same. Okay, so for example, let me just do one real quick. 2 3/5. Okay, so let's do 2 3/5. 2 3/5. I would start by multiplying the 5 times the 2, right? Okay. The reason we can do that is because each one of these wholes is 5/5. You know, this is 2 wholes. You know, I have a 1 and a 1. You know, I have 2 whole would be a 1, right? So I have 2 wholes, and each of those is 5/5. So if I multiply this, I get 5 times 2, I get 10/5, right? So that's going to go up here. So what I have is 5 times 2. I'm going to use a dot for times. Okay, and then plus 3. Add the numerator. Okay, and then we would just carry over the denominator of 5. Okay, so we have 5 times 2 plus the 3 over 5. Okay, which is 5 times 2 is 10, plus 3 is 13, so that would give us 13/5. Okay, as the improper fraction form of this mixed number. Okay, 5 times 2 is 10, plus 3 is 13. Okay, so we can kind of do it that way quickly. Okay. So that was our first example. 5 times 2 is 10. 5 times 2 plus 3 is 10 plus 3, which is 13/5. Our second example, we'll look at 4 7/8. So we're going to get 8 times 4 plus 7. So I'll kind of show the little shortcut there, but you do a times there, dot for times, and then do a plus there. Okay, so we go 8 times 4 plus 7. Okay, so 8 times 4 is 32, plus 7 is 39, and we just carry that denominator over. So we keep the same denominator. Okay, now let's look at how we go from improper fraction to a mixed number. Okay, and say we'll look at converting a positive one to start. Okay, so our first step is divide the numerator by the denominator. Okay, because a fraction says divide, right? Find the quotient and the remainder. Okay, the quotient is the integer part of the mixed number. Okay, the remainder is the numerator of the fraction in the mixed number. Okay, and then the denominator doesn't change, will be the same. Okay, so let's look at an example here. Let's say we have well, we did 8/5, but let's do something different. Let's do 12/7. Okay, so I'm going to take 12 divided by 7. Okay, so 12 divided by 7, I can go, now remember, we're taking 12 goes inside our division sign and 7 goes on the outside. And 7 goes into 12 one time. We take out the 7, right? And we get 5. So there's our remainder is 5. Okay, so there's a remainder. There's a quotient. Okay, so we're going to say our answer is 1. There's the quotient there we're using. And then 5/7. Okay. So here's quotient, right? Our answer is the whole number part. Okay. The integer part, and then the remainder is the numerator of our fraction, and then the denominator stays the same. So 1 5/7 is the mixed number version of 12/7. Okay, let's look at 8/5. So we're taking 8 divided by 5. Remember, this is the number you're dividing up and you're seeing how many 5s you can take out of it. So the 8 goes here and the 5 goes here. So 5 goes into 8 one time. Subtract the 5. We get 3 as our remainder. Okay. So our answer is going to be 1 3/5. So our quotient was 1. That's the integer part of the mixed number. Remainder is the numerator, and the divisor, the denominator stays the same. Okay. So our mixed number version is 1 3/5. Okay, let's look at one that's a little more calculation. 225 divided by 8. Okay, so when we're dividing, remember long division, first we try to go 8 into the first digit. It doesn't go into 2, right? So now we go to the first 2 digits. Okay, 8 goes into 22. We're going to ignore the 5 for a minute. And it helps if you put decimals, at the end of your number, so you know where those decimals line up, and line them up on the top too. So you kind of have your place values all lined up. So 8 goes into 22 2 times. Okay, so we're going to put the 2 in front of this 2, right? And then 8 times 2 is 16. So we subtract 16, we get 6. Now we bring down the next place value, which is that 5, right? So now we're at 65. Okay, 8 goes into 65 8 times. So 8 times 8 is 64. We subtract, we get 1. Okay, so here's our quotient, right? Here's our remainder. Okay, so our mixed number version is going to be 28 quotient and 1/8. Remainder is the 1 there. Okay, so you can see the 1 goes here, and the quotient goes there, and then the denominator stays the same. So there, again, here's our quotient, here's our remainder, here's our divisor. We'll look at some long division examples in class 2s to kind of give you some practice, and I'll have you guys do some as well, because it may have been a while since we've done this, I'm assuming. Okay, here's an important property of rational numbers. Okay. A rational number as a decimal number will be either terminating or a repeating decimal number. In other words, either the decimal stops, like for example, 1/4 is 0.25, or it'll have a repeating pattern. Okay. Like this one just repeats 3. 1/3 is 0.33333, ... Okay, keeps going, right? So it's going to have some sort of repeating pattern, or it's going to stop. Terminating means it stopped. Okay, and we can write that repeating decimal as, if you've got a repeating pattern, put a bar over that pattern, and that just says the 3 just repeats. Okay. So here's some terminating decimals. 0.5, which is 1/2. 0.75, which is 3/4. 4.65, which is 4, and 65/100ths. Okay, we can reduce that fraction. Okay. Again, we looked at our repeating decimal, 0.33333, ... which we can write as 0.3 with a bar over it. It means 0.3 repeating. Okay. You might have a repeating pattern that has 2, like this one is 0.232323. So we would put the bar over the 23 because that's the pattern that repeats. Okay. Or you might even have a pattern that repeats after a couple digits have already gone by. So this one goes 8.13456456456. So the 1 3 doesn't repeat anymore, just the 456. So we can see that this is our repeating pattern, 456, 456, 456. So we're just going to put the bar over the 456 part. Okay, we show the 1 3, of course, but you see the bar just goes over the repeating part. Okay, let's look at a couple examples. Just show that these rational numbers terminate. Okay, so 4/5 is 0.8. If we divide 4 divided by 5, we get 0.8. Okay. That stops, right? Minus 21 over 25 is minus 0.84. Okay. 97 over 40. Now this one is an improper fraction, but the decimal would be 2.425. These decimals stop. Okay, so here's examples where the decimals terminate or stop. Okay, here's some examples where rational numbers where the decimals repeat. So 2/3 is 0.6666666, etc. Okay. 14 over 99 is 0.14, repeating. 1 5/36. Now this is an improper fraction, or this is a mixed number. We can write this as an improper fraction. So let's do that. Remember, we're going to do 36 times 1, because our plus 5 over 36. So this is our 36 there. So 36 times 1 is 36 plus 5 is 41. So we could also write this as 41 over 36 as an improper fraction, that mixed number. And we get 1.138, and the 8 repeats on that one. So this one is a repeating pattern. Okay, here's a cool thing you do with nines. Now, watch this. 1/9 is 0.1111, etc. Okay, 2/9 is 0.2222, okay, etc. 3/9 is 0.333, 4/9 is 0.444. When you get to double digits like 99, notice the 1/4 repeats, okay? So we could also do something like this. We could say like anything, like 23 over 99 is 0.23 repeating. Okay, 0.232323. And then we can go to 3 digits. So let's say 147 over 999. Now I'm doing 999 now. So now I have 3 nines. That means the 0.147 repeats. Okay. Whenever you're dividing by all nines, okay, like 99 or 99 or 999, that sets a repeating pattern. This says a repeating pattern of 1 digit, which is 2. Okay. This says a repeating pattern of 2 digits, which is 14. This says a repeating pattern of 3 digits, which is 147. So it's kind of a cool thing you can do with if you're dividing by 9 or 99 or 999, or anything that's all nines. Okay, let's talk about converting decimal numbers to fractions. Okay. So we can convert terminating or repeating decimal numbers into a quotient of integers, okay, or a rational number, right? Okay. So we're going to refer to the positional values to the right of the decimal point, okay, when we talk about how we do this. So place value is important, okay. Remember the number right in front of the decimal point is your ones place. Now as we get to the decimals, the one right after the decimal point is your tenths place, okay, 1/10. So we have 2/10 here. The next one is your hundredths position, 8 over 100. So let me write the fraction parts of these so we can see how they correspond. So this part is 2/10. Okay. This is 8 over 100. See, that's hundredths. 5 with a th. 5 thousandths. This is 7 10,000ths. See how we're getting smaller and smaller by a factor of 10 in the denominator? This one is 1/100,000th. Okay, 100,000th place. And this one is 4 millionths. We're getting smaller and smaller fractions there. Okay, so our place values, you can see, as we get past the decimal, we're multiplying our denominator by 10 every time. We're going by a factor of 10. So tenths are dividing into 10 pieces. Now we're dividing into 100 pieces and 1,000, etc. So these are really tiny parts as we go further and further down the decimal. Less and less significant. Okay, so there's kind of a trick to this. When you see a repeating pattern, you want to get your decimal right in front of that repeating pattern. Okay, and it's not right now because we have this 12.142 and then the 2 repeats. So we start by using little n, to represent our number as it is. Okay, and then what we're going to do to n is we're going to multiply it times 10 or 100 or 1,000 or whatever it takes to make your decimal go over here. Okay, we want the decimal to go over there. Okay, so we just have the repeating pattern after decimal, nothing else. We get this other stuff out of there. So if we multiply n times 100, it moves our decimal over 2 places. See that? Okay, and that's kind of the trick there. So we got n and we got 100n. Okay, now if we take this 100n, okay, and multiply it times 10 again, you're going to get that repeating pattern again. And the idea is we're trying to get rid of that repeating pattern. Okay. So if we take, now we're talking about 1,000n, right? Where we have the same repeating pattern, but now we had to move the digit over 1, right? So we have 1, 2, 1, 4, 2. Okay. Now if you take this thing, this 1,000n, minus this 100n, that 0.2 repeating goes away, right? So if we take 1,000n minus 100n, these cancel out, so we don't have the decimal anymore. And then we just do the subtraction of the integer part, and that gives us 10,928. And when we take 1,000n minus 100n, we get 900n, okay? And then we can write our fraction just dividing both sides by 900. as n equals 10,928 over 900. Okay, and if we reduce it, it would be 2,732 over 225. So that's sort of the trick to this. It's a little involved, and I'll look at examples in class. But the idea is that first you want to start with the number as it is, call it n, and then multiply the number times 100 or 10 or 1,000, whatever you need to do to get the repeating pattern right after the decimal. Okay, and then create another number which gets that repeating pattern after the decimal. Okay, a bigger number. So we multiply it by times 10, and it gets that repeating pattern after the decimal. And then subtract the bigger number minus the other big number. And then we're going to get those repeating patterns to cancel. So we want to get two numbers with that repeating pattern right after the decimal. So when we subtract those two, they cancel out. Okay, let's talk about multiplication of fractions. Okay. We don't need to find a common denominator. Okay, we just multiply the numerators together and multiply the denominators together. That's all we do. So we don't need to get a common denominator. We can just say if we have, here's an example, just using any numbers, a over b times c over d, two fractions. We just multiply a and c, and we multiply b and d. Okay, and then this is the same as multiplying. When you see them together, that means you're multiplying. Okay, so we just multiply numerators, multiply denominators. Pretty easy. We have to make sure, though, that b is not equal to 0 because that's in the denominator of this fraction. And we also have to make sure that d is not equal to 0 because that's in the denominator of this fraction. So we have to specify that we can't have zeros in our denominator because you can't divide by 0. Okay, let's look at some examples. Let's say we have 3/5 times 7/8. So that's just, we don't have to have a common denominator when we're multiplying. So we just multiply 3 times 7 in the numerator and 5 times 8 in the denominator. 3 times 7 is 21 and 5 times 8 is 40. Now, when you multiply fractions, you have to make sure that you reduce your fraction. Okay, in other words, it should be in simplest form. So we might have to find a greatest common divisor or greatest common factor that goes into both of these. Now, in this case, we don't have to worry about it, but here we might. Okay, actually, it's not an issue here either. So, minus 2/3 times minus 4/9 is minus 2 times minus 4, which is a plus 8. And then over 3 times 9, which is 27. So our answer is 8 over 27. Okay. If you're multiplying mixed numbers, convert them to improper fractions first when we do the multiplication, because you can't really multiply mixed numbers as they're written. You've got to make them improper fractions. So this is 8 times 1 plus 7 is 15/8, and 2 times 4 plus 1 is 9/4. Okay. And then we do our multiplication. So 9 times 15 is 135. 8 times 4 is 32. And then if you're given mixed numbers to start, you should put mixed numbers in your answer should be in mixed number form. So we should convert this back to a mixed number. 32 goes into 135 4 times, and then there's a remainder of 7. So that's if we do our division, that's how we get that 4 and 7 over 32. Now here we didn't have to reduce our fractions, but sometimes we do. Like, for example, let's say I'm doing 3/4 times 2/9. Okay. Now, if I multiply that just as it is, I would get 636, right? But what you can do with multiplication of fractions is you can reduce it before you do the multiplication. And what you can do is, first of all, see if your fraction can be reduced. So 3/4 can't be reduced and 2/9 can't be reduced, but you can reduce diagonally too. So like 2 and 4 both have a common factor of 2. So what I can do is say divide by 2 here, I get 2. Divide by here, I get 1, right? And then I can do the same thing with the 3 and the 9 going diagonally. See, because we're looking at numerator to denominator, and you can always divide common factors. So 3 goes into both of these. So now I can do this. Divide by 3 here, I get 3. Divide by 3 here, I get 1. Now, not only is our multiplication a lot easier, but it'll be in reduced form when we're done. 1 times 1 is 1, and then we have 2 times 3 in our denominator, which is 1/6 for our answer. So you can do that reduction, and I would advise you to, before you do the multiplication. Here we don't have an issue with that, or we don't have common factors in any of these, going up and down or diagonally. Okay. You can't go across, just up and down or diagonally like that. Okay, we look for common factors. But here we have 2 and 4, and here we have 3 and 9. So that's a trick that you should be doing before you do the multiplication, because it makes it a lot easier when you do it, and then your answer is already reduced when you do your multiplication. Okay, let's talk about the concept of reciprocal. Okay, reciprocal of any number is 1 divided by that number. Okay, so think of like reciprocal of 3 would be 1/3. Okay, reciprocal of -2 would be -1/2. We keep the negative the same. But you can also do it with fractions. So let's say I have 3/7. Reciprocal of 3/7, we just flip the fraction. If we divide by that number, we just get 7/3. Okay. So we can also think of reciprocal as just flipping your fraction. Okay. When we multiply a number times its reciprocal, we always get 1. So the product of a number and its reciprocal must equal 1. Okay. So 3 times its reciprocal of 1/3 is 1. Remember, we're flipping the fraction, right, to get the reciprocal. So 3/5 times 5/3 gives me 1. And then -6 times -1 over 1 over -6 is also 1. So you multiply a number times its reciprocal, you get 1. Now we call that a multiplicative inverse. So another term for reciprocal is multiplicative inverse. And you can think of your multiplicative inverse as sort of like the opposite of a number when you're multiplying. Okay, so if you multiply a number times its opposite, you're going to get 1 for multiplying. Now that 1 is called our identity element. Okay, and that is when you multiply times 1, you get the same number. So that's kind of what our identity element for multiplication is. And when you multiply a number times its opposite, its inverse, it's reciprocal, you'll always get that identity element. So that's the idea here when we talk about reciprocal. We're looking at kind of the opposite of the number. Just like when you're adding, the opposite of a number is the negative, or change of sign, like 3 and -3, or -1/2 and +1/2, right? When you add those up, you get 0, which is your identity element for addition. If you add 0 to a number, you get the same number. When you multiply times 1, you get the same number. So that's the identity element for multiplication. We'll actually look at that in chapter 10 a little bit for groups. Okay, so for division of fractions, quotient of two fractions, we multiply the first fraction by the reciprocal of the second fraction. So another way to look at that is to say this. If you remember this expression, flip the second guy and multiply. Okay, so basically, if you're taking a over v divided by c over d, you flip the second guy, so take the reciprocal, change it to d over c, and then multiply. Okay, so that's all we do. We turn it into multiplication. And you kind of think of like, remember, d over c is the opposite of c over d. So if we're doing division, the opposite of division is multiplication. So we're doing the opposite to the opposite. And that is the same as doing the regular operation. Okay, it's kind of like two negatives cancel out. So we're doing the opposite of division is multiplication to the opposite of c over d, which is d over c. And then we just multiply. So a times d over b times c. Okay. Now here we have to say three things. B can't be 0 because it's in the denominator here. D can't be 0 because it's in the denominator here. But also c can't be 0 because now that we flipped it, it's in the denominator over here. So three of these things cannot be 0. Okay, and if you're going to reduce, like I talked about, up and down and diagonally, make sure you do it after you flip the second guy and multiply. So make sure you're in multiplication mode before you do that, okay? Because you can't do it with division. It's a little bit different, right? So do the change first and then reduce your fractions, cross off things if you can. So here's some example division. 3/8 divided by 5/7 is the same as 3/8 times 7/5. We can't reduce anything up and down or diagonally, so we just multiply 3 times 7 and 8 times 5, we get 21 over 40. Okay, minus 2/9 divided by 3/13. So let me cross out this minus because this should not be here. That was a typo. So the minus is already up there. Okay, so that's the same as saying minus 2/9 times 13/3. Okay, now notice we can't cancel anything here or diagonally in either way, okay? So we're just going to multiply the numerators. Minus 2 times 13 is minus 26, and 9 times 3 is 27, okay? And don't forget the negative. So your answer is minus 26 over 27. Now be careful, because remember I said you have to change it to multiplication first before we reduce. If you forget that, you might be tempted to factor out a 3 here and a 3 here, but you can't do that because you're dividing. So you got to be careful. You don't do this cancel out, a 3 here and a 3 here until we get it to multiplication. Then do the canceling, because nothing should cancel out here. Okay. So we change to multiplication, then see if we can cancel stuff out. Okay, addition and subtraction of fractions. Here is where we need the common denominator. Okay, so if we with the common denominator, it's easy. Okay, we just add or subtract their numerators and retain the common denominator. So keep the common denominator. So if we have a over c plus b over c, common denominator, right? Then we just take a plus b over c. Make sure our c is not 0 because it's in the denominator, right? Okay. If we have a over c minus b over c, we keep the common denominator of c and just take a minus b. So subtract the numerators. Again, c cannot be 0. So that's pretty easy if we have a common denominator. If we don't, we have to find it. Okay, so here's an example of 1/8 plus 3/8. The 8 stays the same, right? And we're adding 1 plus 3, so that's just 4/8. Now here's where we have to reduce our fractions. So you can think, well, 4 goes into this 1 time, and 4 goes into that 2 times, and that's where we get our 1/2. Okay, the second one, 19/24 minus 5/24, common denominator of 24, so we just keep it the same, and just take 19 minus 5, which is 14, and here we'd have to divide by 2 on the top and the bottom. Divide by 2, you get 7. Divide by 2 here, you get 12. So that's how we reduce our fraction, dividing by 2 on the top and the bottom. Okay, so for common denominators, it's not a big deal. You just add the numerators or subtract the numerators and keep the denominator the same. If they're different, it's a little more work. Okay, let's talk about the fundamental law of rational numbers, and it says this. If a, b, and c are integers, b is not 0, and c is not 0, because they're both denominators, then a over b is equal to a over b times c over c. In other words, which is just a times c over b times c. In other words, we can multiply the top and the bottom of any fraction times the same number as long as it's not 0. Okay, so c can't be 0. So we can multiply anything on the top and the bottom and still get what we call an equivalent fraction. Okay, so this fraction and this fraction, a over b and a times c over b times c, are called equivalent fractions. They are the same. So for example, let's say I have 2/3. Okay, I can multiply the top and the bottom times 4 over 4. Okay, not 5, 4. Okay, 4 over 4. Okay, and I get 2 times 4 is 8. And 3 times 4 is 12. So we can say that this fraction, now my c is 4 here, right? So we can say this 2/3 and 8/12 are called equivalent fractions. Okay, so those are equivalent fractions there. Okay, multiplying the top and the bottom times any number that's not 0. Okay, so the last topic we'll look at here is adding or subtracting fractions with unlike denominators. Okay, so we first have to rewrite each fraction with a common denominator. Then we add or subtract the fractions, okay? Which means you're going to add or subtract the numerators, okay? So, for example, let's say I have 1/2 plus 2/3, right? Now we can think of pizzas, okay? And if you think of pizzas, 1/2 would be your pizza's cut into 2 pieces. Remember what your denominator is. It's how many pieces your whole is cut into. So the first pizza is cut into 2 pieces, okay? And I have 1 piece left. So the numerator tells you how many pieces you have. So we'll fill that in, okay, like that, okay. And then the other one, I have a plus here, is divided into 3 pieces. So you can do 3 with like a peace sign, right? Okay, kind of thirds there. Okay. And so now my pizza's cut into 3 pieces, and I have 2 of them left over. Think of it like leftovers from a party or something. So I got 1 there, and I got 1 there, okay? But I can't just add these together, the 1 and the 2, because they're different sizes. This one's bigger piece than this one. So what I have to do here, and I'll do this in a red, is make some cuts in my pizza to make things even, right? So if I cut my pizza, my first pizza, into 3 pieces for each half, okay, like that, okay, and if I cut these into 2 for each third, right, now I have 6 pieces in each one. See that? I have 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, all the same size, or they're supposed to be, right? So now instead of 1/2 plus 2/3, I have 3/6 plus 4/6. You see now each of my pizzas have 6 pieces and they're the same size. So, and then I can just add those and I get 7/6, right? Okay, which is an improper fraction, but that's fine. You can leave it in that form. So this is how we do it using our pizzas. We have to cut them, right? So that the pieces are the same. We can say, okay, if we're sharing this up at, after the party, we want to make sure everybody gets the same amount of pizza. So we got to cut the pieces up so they're the same size, because this has bigger piece. This is a bigger piece than these two, right? So we cut these into threes into thirds, and we cut these into halves, and they come the same size. Well, what we're doing with the fraction here is we're multiplying the 1 and the 2 times 3 and times 3. And then we're multiplying the 2/3 times 2 and times 2, kind of following our fundamental theorem of rational numbers, right? So that's how we get the 3/6 over here and the 4/6 over here. So the pizza helps you see how to visualize that, but you don't need to draw that every time. Just if you recognize that your common denominator is going to be 6 here, that's your least common multiple. It's the smallest number that both of these go into. Is 6. 2 goes into 6 and 3 goes into 6. And that's the smallest number where that happens. That means we have to get 6 here, so we're going to multiply times 3 here and 3 here. We have to get 6 here, so we're going to multiply times 2 and times 2 here. Okay, so that's how we get what we call our equivalent fractions. 1/2 is 3/6 and 2/3 is 4/6. And now we can add our numerators. Okay, finally, let's just look at one more example. Let's say we have 13/15 minus 5/6. Our common denominator here is 30. See, 30 is the smallest number that both of those go into. Now, how do we determine that? Well, what you can do, one trick you can do is you can take your bigger number and just start looking at multiples of that. So 15 times 1 is 15, right? And does 6 go into 15? No. Okay, so we're going to try another one. Okay, let's go 15 times 2. Okay, 15 times 2 is 30. Okay. So we know 15 goes into 30 because we just did it, right? Now we say, does 6 go into 30? And yes, it does. Okay, so that would be our least common multiple or our least common denominator. Okay, LCD or LCM, whichever you want to call it, least common multiple, least common denominator. So we want to get 30 as our denominator. So to do that for 13/15, we have to multiply times 2 on the top and the bottom. 15 times 2 is 30. Okay, and then 13 times 2 is 26. So here's our equivalent fraction for the first one. Okay, and then we need to get 30 over here, so we're going to multiply 6 times 5. Okay, and also do the 5 times 5. So 6 times 5 is 30, 5 times 5 is 25. So our equivalent fraction for minus 5/6 is minus 25/30. Okay, now, see, the pizza it'd get a little messy because we have to make all these cuts. So we won't worry about trying to visualize it with a pizza here. Okay, so now we have 30 and 30 as our common denominator, which means all we have to do is subtract the numerators. 26 minus 25 is 1, and 1/30 is our answer. So remember, we don't do anything to our denominators. We just keep them the same as once we have a common denominator. We do have to change them if they're different, right? But we're going to have to change them to is something so that they're the same, right? Like 30 for this case. Okay, we'll do some examples in class and go into a little bit more detail.